Hello. Hello? Hi, everyone. Well, I think we're going to get started. My name is Paul Gus Marino.
And I'm Nick Kramer. So this is the Building Great Apps for Xbox with Universal Windows platform. Let's try that again. I'm Nick.
Woo!
Thank you. Sorry. So this is the Building Great Apps for Xbox using the Universal Windows platform. And just to hammer that home, this is about building great apps, not about building great games. Great games are a great thing, but a different talk. So how many of you have developed using the Universal Windows platform?
Woo!
Great, almost everyone. That's awesome. I love you. How many of you have used an Xbox before? Just picked up a gamepad, played Xbox? Almost everyone here. Everyone
Excellent.
loves Xboxes. Everyone loves UWPs. How about who's developed apps for an Xbox before? Surprising number of hands. So, take it, Paul.
This talk is for all about how to get your app here on the Xbox. And we're going to talk about how to use the Universal Windows platform to create an app that works great on the Xbox and great in that 10-foot environment. We're going to dive deep on gamepad and remote. We're going to talk about interaction modes and all the buttons and inputs and behaviors of the controller. We're going to talk about tuning your XY focus experience and focus engagement visualization. We're going to dive deep on presenting on the TV and sizing of UI and colors and sounds. Throughout the talk, we're going to use slides to show concepts. We're going to show a real app running. We're going to show real code. We're going to do some debugging in Visual Studio. At the end of the talk, if we have time, we'll do some questions here. Otherwise, we'll be available outside to answer questions. UWP on Xbox. This presents a pretty awesome opportunity for all of you to reach millions of more customers and an entirely new environment, the living room. And I'm sure a lot of people's heads are starting to think about the cool apps they could bring to the Xbox. You're starting to think about media apps and news apps and shopping and business and entertainment and education and so forth. And there are a lot of exciting opportunities. And as you think about those, one of the things you'll want to think about is that there is a different environment that the Xbox presents than a traditional PC or a phone environment. There are different expectations those users have, and you need to do a good job meeting those expectations and fitting into that environment for people with your application. And we call that environment the 10-foot experience, or the 10-foot environment. And it's different if you think about it. You're sitting across the room from a television. Maybe you're sitting on your couch. There might be distractions in the room. There's a dog on your lap. There's kids crying. There's people doing things. You're using a controller to interact with it. Maybe there's multiple people interacting with it at the same time. It's a different environment. Certainly different than being hunched over your laptop or with a phone up in your face. And so you need to think about that. And it's not just how people interact with apps, but it's what they do with apps. They might have different expectations about what they want to do with the app there. A shopping app might all of a sudden become social because there's other people participating in that app and watching it and using it with you. A news or business app might want to present ambient information that's cycling through all the time because people might be doing other things around their home while they have this app up on the screen. So not only is how you interact with the apps different, but what the apps should do and what people might want of the apps different. And so when we think about this, we think there's three big things we recommend everyone keep in mind when they're targeting the 10-foot environment with their app design. The first is make it simple. The amount of information displayed should be comparable to what you'd have on a mobile phone more than what you'd have on a PC desktop screen that size. The TV resolution and viewing distance make UI harder to see. Again, there are other distractions going on. Make it simple. Second, we'd like to say make it coherent. Arrange content so that movement across the space is consistent and predictable. Make the focus clear and unmistakable. Give people the shortest path to get where they're trying to get and do what they're trying to do. Again, someone's sitting there with a remote, dogs are barking, children are crying, things are going on. Make it coherent. And finally, make it captivating. The most immersive cinematic experiences take place on the big screen. Make things go edge to edge with scenery and amp up the amount of motion. I don't know how many people went to the beautiful UX talk earlier today, but think about motion and animations, vibrant use of color, typography, make it really captivating experience and draw people in. And so I'm telling you all this kind of guidance around the things you'll want to do with your app when you target 10 foot, and how does that relate to universal Windows platform and universal apps? How do we think about that? Because it's a platform that runs the same app on a PC and a phone and a tablet and Xbox and all those things. And the way we think about it is that you can reach every Windows device with one app, and that the platform that we're giving you, the UWP platform, is a WYSIWYG platform. It's a what you see is what you get platform. If you say to make a pixel red, we make that pixel red. If you tell us to play a certain sound or do a certain animation or have a certain interaction, we do that reliably for you, because that's what empowers you as developers to really control your experience. And that saves you a lot of time where you're not crazily debugging things, working differently, and so forth. But that does put a little bit of work on you, and we think a very coherent and modest amount of work to tailor that one experience for the different environments and for example, the 10-foot environment of the Xbox. So I think the best way to kind of really grok what we're talking about here is see a demo of that. And so, Nick, why don't you show us that?
Yeah, so I was sitting on the couch the other day with my nephew playing an Xbox game, and his father walked in, said to his son, "Have you done your homework yet?" Of course he hadn't. He's a kid. And turns out he has a report due on the next day on the presidents. Has to write a report on who was the greatest president and why they were so great. And I thought, wouldn't it be great if he could do that homework on his Xbox, do the research on his Xbox? Now, I already have a PC app that's exactly the material that he needs to do, but it doesn't work on an Xbox yet. Let's just check this app out. So it's got all the key information there about George Washington and all the other presidents. You can navigate through the presidents. You can navigate to his rotundity, the apostle of democracy. You can see little Jemmy, the last cocked hat. I didn't make these names up. I don't know where these nicknames came from. It supports navigating back. Supports different pages. You can see all the Democrats, all the Republicans. You can expand and collapse this nav bar. You notice the fine visuals we have on this thing. The little French fry is what we call this little selection doohickey to show you which is the selected tab in the navigation bar. So it also supports a couple good features like resizing. Let me expand this out just to show you the full glory here. So like any good Windows app, it's resizable. Number of columns change. You see how the navigation bar collapses when you get small. When you get even smaller, it disappears entirely. It supports going full screen like a good Windows app. You can tab through this application. Go down to the feedback and the settings button, and when you get out here, you get a focus rectangle. Now, this is the kind of focus rectangle you're used to seeing on an Xbox. We loved them so much, we brought them to the PC. You can see them in the Start menu as well. Every XAML app that targets the Windows 10 Anniversary Edition automatically gets the new high visibility focus rectangles. So let's check out what this will look like on an Xbox. When we're done tailoring everything, we'll have supports gamepad navigation. With the volume, can we get volume on this guy? You can hear the world's softest sound playing when we navigate around. If you're about 2 feet from the computer, you can hear it. When you press A, you go in, you navigate around. When you press B, you navigate back. And we can do all the things you expect on an Xbox with a gamepad. You also notice that everything has been sized appropriately for a television. Everything is twice as big. Everything is in dark theme. Xbox defaults to dark theme for its applications. PC defaults to light theme for its applications. So we automatically pick up that dark theme in the application. Finally, we'll notice that the navigation bar over here started off collapsed. It didn't expand out by default. We made an intentional design decision to collapse that navigation bar on Xboxes to give the most content possible for the application. But we also left some space on the left margin of that navigation bar for televisions that need extra margins. We call this property overscan. We also call this the TV safe area concept, where some televisions will clip off the edge of the content, And so you need extra margins around your content to make sure it's visible on all televisions and not just your television. Let's see. And so just to reiterate that, you can see both of these applications side by side and what makes them unique and different. Again, the color, the dark theme versus light theme, the scale factor, the gamepad, the navigation bar differences, let it be tailored for the device you're running on. So how do we do all this with a single UWP application? The biggest thing here is that there is one design language for all these different devices. The same design language for a PC is the design language you use for an Xbox. We created one design language with all of these devices in mind. We provide reasonable defaults for a bunch of different settings. We talked about the theme. We talked about sound is enabled by default on an Xbox. The scale factor, how big things are tuned differently with different defaults on an Xbox so that they're all reasonable out of the box and things just work. And where you choose to have intentional design differences, you can do that with a minimum amount of code. You can have an if statement and make the changes you need to make for the intentional design differences that you have. So let's show how to make some of those intentional design differences. Actually, before I get there, I want to show what this application looks like on an Xbox using the bits you have today without making any changes whatsoever. Without changing a single line of code, I F5 deployed this over to the Xbox earlier while a couple of you were watching. What you see is it's up and running. It works with gamepad. All the basic functionality is there. We have a dark theme. It's big like you expect it to be. What you don't have is you don't have sound yet on this particular, the bits that we have available today. And you don't have the high visibility focus rectangle. We have some kind of marching ants is what we like to call them. We love marching ants, but it was time for them to go. So that's, with the bits you have today, that's what we get out of the box without a single line of code change. We'll also note that there's big margins around this to make sure it runs on all televisions, but it's not as beautiful as it could be to optimize for those televisions that like to clip content. But I want to show you what it can look like when we're finished. I want to show you two new features that we've just finished that haven't made it onto the Xbox into the preview build of the Xbox yet, or into the preview build period. We have focus rectangles and sounds we just finished implementing and are not in the preview build yet. I want to show you those. I also want to show you how to do intentional design differences in your application. So you can do 10-foot mode on a PC as well as on an Xbox. Your Xbox is a 10-foot optimized device, but your PC can be a 10-foot optimized device as well. And this makes sense for some applications. Media applications, for instance, they may be built for college students who have a dorm, they don't have a television, they put their computer at the other end of the bed, they put their computer into TV mode or 10-foot mode, and that's their 10-foot media experience on a PC. So we want to enable that in our application as well. I have just a simple static field here that I will toggle on and off on whether we want this PC to be in 10-foot mode. And we also want to go into 10-foot mode when we're running on an Xbox. So there's a class called Analytics Info, has a version info property, returns a device family, and that device family is Windows.Xbox if you're running on an Xbox, Windows.PC if you're on a PC, Windows.Phone if you're running on a phone. So that is the key line to figure out, are you on an Xbox or not? Once we know if we're on an Xbox, we can then do something with that information. And we can make some intentional design changes. So what we have here is a visual state group. And visual state groups are just a markup way of writing an if statement. The first block says, if we're in 10 foot, then set a bunch of properties. And there's 3 sets of properties I want to set differently for an Xbox than I want to set for a normal PC, a 2-foot PC. The first is, we talked about this earlier, I want that navigation pane to be collapsed. Give the user that much more screen real estate. The second difference for 10-foot mode is I want that different selection visual for the navigation bar. Instead of the French fry visual we use on the desktop, I want to change the background of the selected item in the navigation pane. Third thing we'll do, and we'll talk more about this later, so I'll just skim over it, is change the navigation bar to be wider and go into that overscan area in a decorative way when on an Xbox and in 10 foot. And when we run this, we'll see that we now have an application that intentionally looks differently when running 10 foot than when it does 2 foot. We'll see the selection visuals are different. We'll see that we've gone into dark mode. See the different, we'll also take advantage of the gamepad working on a PC, and what do you know, makes sound in this one as well, with those high visibility focus rectangles. And you see the navigation bar has that selection color for the selected item, as well as having that extra space on the left of the navigation bar for the overscan area of the PC, or of the television.
Yep, awesome. So that's a super cool kind of overview of kind of bringing a single universal app across PC and Xbox and how you can tailor it. Now let's dive a little bit deeper into some of the big differences that you'll want to kind of optimize for. And the first is gamepad and remote. Gamepad and remote are now first-class input types for the Universal Windows platform. So the same way in the past you might have thought about touch and mouse and keyboard and pen and having your apps work with those, you can now have your apps work with gamepad and remote in that same way, and we encourage you to. When you're using gamepad remote, there are really 2 fundamental ways you can interact with the app. One is what we call XY focus, and the other one is what we call requires pointer. XY focus is how all of you are familiar with interacting with apps on your Xbox for the most part today. You hit right, and the focus moves right. You hit down, and focus moves down. Requires pointer is a way in which you can use the controller to simulate a sort of mouse cursor moving around. And so you'd move the stick around, and the mouse cursor moves around. If you've used the Edge browser app on your Xbox, you're familiar with this. It's how you navigate around web pages, for example. And so both of these interaction modes are supported with the Universal Windows platform and the controllers. Now, XY focus is what we recommend for most UI surfaces. So for the most part, this is what you should be using for most of your UI. And requires pointer, this is useful if you have, for example, a drawing surface, you're writing some kind of drawing app, or you're hosting arbitrary web content that you don't really control the UI content of. Pointer mode is a great way to do that. So how do you set that up? On every application object, there's a requires pointer property that's been added, and its default value is auto. And when it's auto, we as the operating system decide sometimes to default you to XY focus and sometimes pointer focus, depending on the device and things plugged into it. Right now, as a matter of fact, an Xbox will default to pointer mode in your app. And so since you want to have a really great app with a controller, you'll want to actually switch that from auto to when requested. When requested forces it to be in XY focus mode, which is what you want, the mode that you want of interaction, except on child nodes, on controls inside your app that you've specifically said you want to be in pointer mode. All right? So you want to set requires pointer to when requested. It's like, remember this. And then on individual controls, again, if there's a web control or a canvas that you're using for drawing, et cetera, requires pointer, just set that on that with when focused or when engaged. And I'll talk about engagement in a bit. So you've got your app up there. You're using XY focus. It's running on the Xbox. And you want to exploit the gamepad and the remote, these 2 input types. And in some ways, they're the most limited input types we have. If you think about how many touch points there are on a touch screen, or how many pixels you can move a mouse to click, there's a lot compared to just the very limited number of inputs on this. At the same time, it's a very rich input device. It has a lot of buttons. They're very sophisticated controls with the sticks and so forth. So you want to make use of them. There's a few common inputs that are there on both the remote and on the gamepad that you really want to make sure that you're doing the right behavior around. Of course, the first one is the left stick and the D-pad, and that's to move focus around, as we discussed. There's the A button, or it's that select button on the remote. This is the equivalent of click. Okay, so whatever thing has focus, when someone hits A, it should click that thing. That's how you want to make sure that works. B, or the back button on the remote, this is for going back. So Nick showed you, for example, in the President's app, how you could click back in the upper left-hand corner in the title bar area. If you're running an app on the phone, there's the back button in the lower right there on the phone nav bar. You want to support back in apps the right way. And with a controller or remote, B is how you do that. OK, now there's this button. And not many people know the name of this button. But it's called the menu button. It has those 3 little lines on it. And this is the moral equivalent of right-click with the gamepad. Okay, this is how you show a context menu. And the rule of thumb I use is I think this is the button on the right, compared to the view button is the other one. All right, so there's the menu button is on the right, and then the view button is on the left. You can see the little icons that are used on those buttons. The view button is for toggling panes or switching views. If you've used the Edge browser on the Xbox, you'll see that's how you open and close the address bar, for example. In apps like the President's app, where you have a navigation pane, you'll want to use that just as a shortcut to toggle, open and close that navigation pane. So these are the kind of the core inputs that exist across both the remote and the gamepad, the ones that are displayed here, that you really want to make sure to support in your app. And it turns out, if you're just building a good UWP app, it's practically free to do so. We talked about how to turn on XY focus. That'll get you the right behavior there. For A and select doing click, as long as you're using the built-in controls, those have all been updated to listen to this input correctly. So if you use a button, just listen to the click event, and it'll get fired when someone hits A on it, or a list view, or a menu fly, or so forth. All the controls are just hooked up correctly. If you're writing your own custom control and you're not using our controls, what you should listen for is the spacebar key event. And by the way, that's something you should already be doing to make your app work well with the keyboard, for keyboard users and accessibility and so forth. So it's just building a good UWP app, this kind of works for you. Same is true with B. If you're building a good UWP app, you're listening to the System Navigation Manager's back requested event. That's the event that gets fired when people hit the hardware back button or the back button in the caption area. So if you're just listening to that event, your app will already work with B. Menu button, same thing. Does anyone here go to Joe Stegman's talk on Windows UI, XAML stuff yesterday? So one of the things that was talked about there was the new context flyout and context requested events. And so if you use the context flyout property or the context requested event to trigger context menus, then you'll automatically get them at the right time with all the different inputs, with long press on touch, and with right click on mouse, and with the menu button on gamepad and remote. So if you just do that the right way, you'll already get this working. And then finally, there's the view button. And this is actually a unique kind of button that exists in the gamepad and remote world. It's not there. There's no equivalent on mouse or touch or so forth. And so for this one here, you actually do need to listen to the gamepad view and navigation view key events to hook that up. And this is kind of, you should think this is a shortcut to get better usage of your app. So, but there's more. Beyond these common inputs, there's even more buttons and inputs on these controllers that you'll want to think about. There's the triggers and the bumpers. And the triggers do page up, down. The bumpers do page left, right. Controls like pivot are already hooked up for you to listen to these. So if you have a pivot control, bumpering left and right will swoosh you to the left and the right and so forth. If you're writing your own UI, you'll want to listen to these events and do that. The right stick, this is used for panning. It's typically when you're in that pointer mode. Since the pointer's moving the mouse around, this is a way you can pan. You'll have seen that in the Edge browser already. But you can also listen to that and hook it up yourself if you have your own UI where you have some panning need. X, Y, these are two buttons on the gamepad that we're, at this time, saying you should use in an app-appropriate way. And it might be different for different apps. We're actually interested to see what you do with them and how you guys use them as an ecosystem and learn from that. and see what people connect them to as shortcuts. Like I've seen a bunch of people start to use Y as a shortcut for search. So maybe that'll emerge as kind of the pattern there. And so we kind of look forward to seeing how you use them in app-appropriate ways. And finally, there are the various media buttons on the remote. If you use the standard media controls, those will work for you. And if you're building your own media controls, you should make sure to test with those and hook them up and work with them. But overall, there's a lot of cool buttons. There's a lot of inputs with these controls. Really exploit them, because customers will expect that. They'll be disappointed if things they expect to work don't work. And if you're building UWP the natural way, a lot of stuff will just work for free for you. So let's talk about tuning XY focus. We said you get XY focus for free, and you do. And I want you to understand how that works a little bit and how you might tune it to get an even better experience. In general, if you're on an element and someone hits the right button, it'll use our heuristic algorithm to search out to the right and find the next UI element that we think should get focus and move focus to it. One of the things we check for is for the element to have tab stop true and visibility visible on it. So if it's not tab stop or it's not visible, we're not going to move focus to it automatically. So that's one thing you might want to pay attention to. But if it is and our algorithm finds it, we'll move there. Same thing moving down. We'll search out with our algorithm and find something that we think is the right thing to go to and move down there. You should note that sometimes different elements will all point to the same element effectively. Okay, so here, this bottom middle element, if I hit right on that, it'll find the far right element and move there. But you know what? So will the top middle one. It'll also find that one and move there. Okay, so sometimes multiple elements might move to one element. So be aware of that. That may or may not be what you want, but that's the default of how it'll work. And conversely, sometimes, depending on how you've laid things out, you might have wanted the right to find something and it won't find it. Okay? And so because of that, we give you control to tune the experience. There's an XY focus right, left, up and down property on every element, and you can use that to tell us exactly where you want that focus to move. So if you want to tune it, you can do that, and you're in control of doing that. If the heuristics and the kind of standard thing isn't working. So we definitely recommend you go test out your UI with XY focus and see, is it working the way you think customers are going to expect, the way you expect? And you might try layout changes, or you might try tuning this way to do that. Why don't we see how you kind of take an app and optimize it for a gamepad this way?
So one of the keys that we wanted to handle was the view button. When you press that view button, the double square button, we want to open the navigation pane. So the way we do this is, first we realize that this thing is actually a funny little keyboard. It fires keyboard events, fires key up and key down. It responds to tab stops. It's basically a funny little keyboard with keys you've never heard of before. So that's what we're going to do. We're going to handle key down event on the main page. And when we do that, we get an event args that has two properties that are interesting to us. There's the key property off the event args, which is the keyboard key that most resembles the gamepad thing. So if you do a D-pad left, then you get the left arrow key on the keyboard as your key field. The other one is the E.original key, which is the original gamepad key as it exists on the gamepad. So you will hear about the D-pad left rather than the keyboard arrow left. You will hear about the A button rather than the space button. You will hear about the view button rather than, well, the view button, because there really is no keyboard equivalent of the view button. So we're going to listen to the original key of gamepad view and original key equals navigation view, which is the remote control equivalent of the gamepad view button. And when you press either of those keys, we're going to toggle the toggle pane button. We're going to check it. We're going to put focus on it. And when I first coded this up, I didn't include the sound. And I got to tell you, it just felt wrong when I used it. So I had to add the sound. So element sound player dot play, and then the name of the sound we want to play there is invoke. And that just felt right. The last thing here actually makes no difference for this particular example, but it's a good habit I want you to get into. E.handled equals true just means that we've taken care of this keystroke. No one else needs to do something in response to this keystroke. Where this really makes a difference is when you're handling arrow keys. If you handle an arrow key on a D-pad, or the A button on a D-pad, or the B button on a D-pad, if you mark that as handled, no one else tries to handle it. If you don't mark it as handled, you did something, and then the XY focus algorithm kicks in and tries to do something else. So that's why we want to get into the habit of marking things as handled when we've handled them. So when we run that, we'll see that by pressing the View button, we open and close it. We get the little sounds. You just do that all day long, dance a little dance there. I also want to show you, while I'm in here though, I wanted to show you a bug I noticed the other day. So when we're on the next page here, we're on the next button here, I hit gamepad left, and focus disappeared. It went into no man's land. There's a little clue here, that little, you just missed it. The toolbar or tooltip there just popped up that said settings. If I go left again, I find another mystery tab stop, but another mystery tooltip that says feedback. Well, having debugged this the other day, I can tell you what's going on here. These buttons here were what was grabbing focus. Let me show you one other thing, though. When I hit the tab key on a keyboard, I put down the gamepad and hit the tab key, same problem. Mystery tab stop, next button. So it didn't work on a gamepad, and it didn't work on a keyboard either. It rarely works any better on a gamepad than it did on a keyboard. So let's debug that. Let's figure out what's really going on. The easiest way to do this is to put in a got_focus event handler and just log whoever has focus. Every time focus changes, debug.writeLine the guy who has focus. Focus manager.getFocusedElement tells you who has focus, debug.writeLine that thing out. And so what we see here is going through that log in the output window, yep, feedback button, the settings button, those guys were the culprits. They were tab stops, they had visibility equals visible, didn't matter that they were clipped. They said they were valid tab stops and they were visible. XAML took them at their word. So now that we know what's going on, the fix is pretty straightforward. Let's just declare visibility properly. Set them, when you collapse that nav pane, set visibility property to collapsed on those two buttons. Let's do the same thing when we expand the nav pane, so we make them visible again. And what we'll find is that by properly setting the visibility attributes, we now have fixed both our gamepad and our keyboard experience. Go back to where we were. Hi, George. All right, when we go left from next, we go into the nav bar. No more phantom stops there. Again, when we hit with the tab key on a keyboard, no phantom tab stops. Does the right thing for both devices.
Awesome. Oops. Yeah, that was that code Nick used to debug. Super cool to realize, a lot of the same issues you run into optimizing for gamepad are the same issues you run into making keyboard work well as well. Some more tips for XY focus experience and optimizing it. Set initial focus somewhere reasonable. It's amazing how many apps forget to do this. We generally recommend the upper left for left to right languages, upper right for right to left languages. If you have UI where something is really secondary, put it on something primary. So in the President's app, for example, putting it right on George Washington on the first thing in the list views makes more sense than putting it on the hamburger button in the navigation pane, because it's more likely where people want to start. So set initial focus somewhere reasonable in your app. Lay out elements with a mind to how focus moves, up, down, left, right. Yes, we showed you how you can tune UI to control where focus goes, but if it doesn't make sense to users, they're not going to like it. So realize people are moving up, down, left, right, and lay out your UI in accordance with that. In this case here, that center block with the X on it, it's hard for someone to realize how are they supposed to even get there, even if you use the properties to make that work. Also consider the sizing of UI elements for a clean experience as you're moving focus around. It just feels a lot better if more or less things are the same-ish size as you're moving around, as opposed to small, tiny, big, giant, just things shifting around as you're moving focus around the app. So think about that. Now, there's an interesting case. We call them focus traps sometimes, but I'll just talk about them as a complex interactions. And let's consider this UI here you may have to deal with. I've got a button, a slider, and another button. So I got focus on the button, I hit right. I think everyone agrees it's going to go to that slider. What should hitting right again do? Is it going to change the slider's values, or is it going to keep moving? It's ambiguous a little bit, and if I do what we actually have chosen to do is have it go to the right here, how do I go change that slider's value? And so for cases like this, we've invented something called focus engagement. Again, you can, by doing good layout of apps, you can often avoid these kinds of cases, but sometimes they do make sense and are the right thing, and you want to deal with them. And so what focus engagement allows you to do is set up an element such that a user can engage it, interact with it, and then disengage and go back to XY focus. All right? So in the case of a slider, the way this would work is you'd hit A to engage it, moves focus into the slider. Now, once a control is engaged, all the input, instead of doing XY focus, gets routed directly to that control. So now the control is listening to those up, down, left, right key press events and doing whatever that control does with those events. In the case of a slider, it moves the slider. Okay, so hitting right again, for example, would change the slider value. When the user's done, they'll hit B. That'll disengage. And now you go back to ordinary XY focus and hit right and goes to the right. All right? So that's called focus engagement. And it's available as a property on all controls. It's the isFocus engagement enabled property. We've tried to set smart defaults for you. So the slider by default does that. It's true. Other controls are false, but you might, depending on the situation, want to change that. And certainly if you're writing a custom control, you should make sure to implement this and support this as appropriate. We'll take questions at the end. So we've talked a lot about focus and making that all work right. And it's really important that you show focus the right way. So can anyone see where focus is here? We talked a little bit about the marching ants, but it's very hard to see, certainly in a television environment, where focus is. And so we've brought the new, that's where it was, if you didn't see it. High visibility focus visuals. So this is the new default, actually, for all apps, on PC, on phone, Xbox, everywhere. This is the new default focus visualization, kind of moving past the marching ants. It's pretty robust. It's the same one that came from Xbox. It works even in complex situations if you have selections and so forth. It doesn't draw always inside the element. It can even go outside the element boundaries. So it's pretty rich. Again, it's on by default. You can control it with this focus visual kind property on the application object. And there's a lot of control to tune it. So every framework element has the focus visual margin and the primary and secondary brush and thickness properties that let you really tune that focus visual to be just right, because again, it can go outside of the boundaries, inside of boundaries. You have a lot of control over it. All the controls have it configured in a nice, good way by default, but if you're creating custom UI elements and so forth, you'll want to take advantage of that. Another thing important around presenting focus is emphasizing focus with light dismiss overlays. So there are a lot of UIs we have in the universal Windows design system and platform that we call light dismiss. That means they are transient UIs. They appear for a moment, you do something, and they go away. Menus, flyouts, combo boxes, and so forth. And for these kinds of UIs, when you're using them with a game controller, focus and keyboard, focus is kind of stuck within that element. And so we want to give more attention to it so the user knows that's kind of where the focus is going to be operating. And so we actually dim the background. So here's before dimming, here's after dimming. All right? And so you want to make sure you do that for these kinds of UIs. We've done it by default for you. So there's a light dismiss overlay mode property on all the light dismissible controls. And its default value is auto. And that, how we interpret that is on Xbox, we automatically dim. On the other devices, we don't. But if you wanted to tweak that, you could by overriding that to on or off and so forth. Again, it's on all the light dismiss controls. If you're creating your own light dismissing type of UI, it's best to derive from one of our controls, usually pop-up or fly-out. We'll take questions at the end, but save that question. All right, so that's getting us a little bit to talking about presenting on the TV itself. We've talked about, so far, about the gamepad and remote and optimizing your UI for that and the things you might want to think about and do. Let's talk about presenting on the TV. So the most obvious thing is UI needs to be bigger, about twice as big. You saw that with the President's app. I think we all intuitively understand that. The way we enable that in the platform in a simple way for you is we actually set the default resolution for apps on Xbox to 960 by 540 effective pixels. Okay? That's conceptually the equivalent of a 200% scale factor on a 1080p screen. Okay? And this results in basically things being bigger. So if you look at the sizing and effective pixels on a phone and laptop or desktop compared to an Xbox, you can see kind of how things size up. The blue dots are to scale in this diagram. And you can see here how big that UI would be if it were run on a PC or it's about a quarter of a screen on a large monitor on a desktop, about 2/3 of a screen on a laptop, about twice the size of a phone screen. So this gives you a little bit of idea of the relative sizing, this diagram here. If you're writing a good UWP app already, you're already writing a responsive app. You're already working with various window sizes. So if your app can size down to 960 by 540 and looks good and works well, then you're all set. If it doesn't, that's something you got to go fix. And by the way, fixing that makes your app better on a PC and all these other devices as well, because people expect them to be responsively designed and work at a variety of sizes. So there's one other consideration in the sizing and layout of your UI. It's not just the overall sizing, this 960 by 540, but TVs have this issue called overscan, and this notion of this TV safe area. Turns out different televisions sometimes crop or zoom up the UI such that they don't actually show the user every pixel that you thought you were sending to the screen. And it's about 5% of the margins is kind of what we consider unsafe. And so in this diagram here, the light blue area we consider not the TV safe area. Only inside there we consider the TV safe area. And that's about 48 effective pixels from each side, left and right, and 27 effective pixels off the top and bottom. To kind of support this TV safe area, what we do in the platform is we actually letterbox your UI. We don't change the core window. We just use this thing called visible bounds, which is a concept in UWP, to inset the UI by the TV safe area margins. But apps should, and we encourage you, to extend to the edges non-essential UI elements. So you don't want to ever put a button someone has to click on in that unsafe area, because then someone may not be able to click on it. But if it's a background image, if it's things that are kind of just completing, showing more list view items ahead of the current one you're looking at, things like that, it's great to go edge to edge on that. So this is a kind of tricky concept, so I'm just going to show a couple pictures to help hit it home. Here's what the President's app looks like with letterboxing. There's a black border all around it. As you can see, on a television that has no overscan, you end up seeing that black border. On a television that has a lot of overscan, thank goodness we had it there, because otherwise you would have cropped a bunch of buttons. All right? Extending it edge to edge, what you're doing is things like the background of the nav pane, things like the list view, you're drawing those to the edge, because it's OK. They're decorative. They don't affect the functionality of the app to do so. And so in that case, on a television that doesn't overscan, it looks much better. And a television that does overscan, it's cropped anyway, so it doesn't really matter what you did. All right, so let's see how you go about doing that.
So let's just pull back a President's app and visualize those overscan margins there with the blue rectangle. So you can see we've already done some optimization earlier with the navigation bar, where the navigation bar background was extended those 48 pixels to the left, those 27 pixels to the top, and the 27 pixels to the bottom. What we should do next is take that image at the top of the screen and move it all the way up to the very top of the screen, get that decorative content all the way to the edge of the monitor, and similarly, take the grid view at the bottom and move that all the way to the bottom of the screen so that you can get the sense that there's more content down there waiting for you. And so the way we do that is with those visual state groups. Again, we're going to do this. If it's a 10-foot, we are going to just add some negative margins to that scroll viewer. There's a scroll viewer that contains both the banner image and the grid view. And we're just going to make it 27 pixels taller, 27 pixels up, 27 pixels down. We're going to give it negative margins, which means take the layout size the layout system thinks I should be, and make it 27 pixels bigger in each direction. So we're actually rendering 54 pixels bigger than the layout system thinks this element should be, which is actually exactly what we want. And when we do that, we're going to see it looks beautiful, but we create a new problem if we just do this. We will have created the problem that if you scroll to the bottom of that grid view, you'll get to the bottom and your last item will be half off the edge of the screen, or half off the edge of some people's screens, I should say. That last item will be into the overscan area of the television. And so we don't really want to trade one problem for another. So let's fix the second problem. The way to do that And this is fairly typical of a lot of overscan optimizations. You tweak one thing, and then there's another thing you got to tweak somewhere else. Doesn't go on forever, but you rarely get away with just one. Really, what we need to do here is set a margin inside the scroll, inside the grid view, and add 27 pixels of padding to the bottom of the scroll view inside the grid view, so that you get 27 pixels, but only when you're at the very bottom of that grid view. And so the way you get at that is you retemplate the grid view. The grid view contains a border. The border contains its own scroll viewer. The scroll viewer contains an items presenter. And the items presenter has the margin that we need to set to 27 pixels. And so when we do that, we're going to see that the content is not only rendered edge to edge on the television, but also, when we scroll down to the bottom, we position that content fully inside the visible area of the television for all televisions, not just some televisions. So let's turn on our overscan area there. And you can see already that the title image has gone outside of the overscan area. If we scroll all the way to the bottom, we can see that we've added those 27 pixels were just enough to get that content into the safe area of the television.
Awesome. A couple other things presenting on television is just colors. Just like for any UWP, you can pick the color scheme that you think is best for your app. If you do default to the system-provided color scheme, on a PC that defaults to white, although there's user setting to change it, and on an Xbox that defaults to dark, so just be aware of that. But take advantage of color there. The other thing to be aware of is what's called TV-safe colors. It turns out televisions don't necessarily present colors in the same range, in the same way that PC monitors and phones do. And so you'll want to be aware of that and try to use colors that are within what's called the TV-safe color range. And what that means is that colors at the extremes, like pure black or pure white or pure red, anything whose RGB, any one of those components, is outside of, is in the 0 to 15 or 236 to 255 range. So any color you can fathom that has that characteristic to it may be TV unsafe. And that means it might get presented in a way that people can't even differentiate it from another color, for example. So it might be that black and very dark gray look exactly the same on that television. And that could hurt your UI, because maybe you had a meaningful distinction there, and now people can't see that contrast and can't see that distinction. And so you'll want to be aware of that. And there's two approaches you could take. One is called clamping, and one is called scaling to deal with that. And we recommend you do scaling. And so that is, rather than just having your black and your off-black look the same to people, we recommend you actually go and tweak your colors across the range to occupy that TV-safe color range while still providing contrast between each color that you're using. So the other aspect, final aspect of printing on TV that's really important is sounds. And you've seen sounds quite a bit, and they're very important in helping users understand the interaction, see what's going on. Platform controls all make sounds by default. It's built into the platform. You can do it on a PC. You can do it on an Xbox. It's on by default on Xbox. And if you're building custom controls, we've actually exposed all those same sounds that we use as part of the platform in a way that you can call them. And so if the sound is on this machine, we'll try to hear them now. Let's see. Yeah. Can you guys hear that? I can do it again. So that's the focus sound. It actually cycles through a set of sounds to create the right focus moving effect. But you just call that API and you get the right one. There's invoke. So that's if you're clicking on a button or some kind of invocation you're doing in your control. There's go back. Okay, it's go back sound. There's show and hide. So if you have like a light dismiss UI or a flyout or some sort of a pop-up that you want to show and then will get dismissed, you want to use the show and hide sound. So here's show. Here's hide. All right, you guys are probably familiar with these from using your Xboxes. And then there's move next and move previous. You might want to use these for things like a pivot. It will do this by default. But if you're having a flip view or some kind of a left and right swiping type of UI, here's move next. And here's move previous. All right. So all those sounds are in the platform, and you can just call them for your own custom controls. So let's see the final part of the demo.
So in order to make the President's app color safe, what I started with is I went over to MSDN, this link up here, cut and pasted this resource dictionary out of this fine documentation we have. which is, by the way, basically the MSDN version of this talk here, so I recommend checking it out. And all this resource dictionary is it's got two different sections. The first one is for the dark theme. The second one is for the light theme. And for each section, it overrides the key 20 or so colors that XAML uses to render the common controls. And so each color is just saying, instead of system alt high color being pure PC black, let's use a TV safe version of black, 101010 instead of 0000. And do that for the 20 or so colors that XAML uses, and then all of your common controls, your default controls, will be color safe. The second part of that is we actually have to use this resource dictionary somewhere. And so in our applications on launched event, when we're 10 foot, then we use that resource dictionary. We just add it to the application resources, add it as a merged dictionary, and there we go. One little trick. Do this in on-launched. There's about 5 different places that are either too early or too late, but on-launched is just right. And when we do that, we're going to see an application that looks remarkably similar to what we just had. To be honest, the effect is pretty subtle in this app. But that's partly because this is not a television. This is a computer projector that was designed for the PC color space. It wasn't designed for a TV color space. When you decide about your TV color safe work, have a thought about actually looking at real televisions. Real televisions are what you're really optimizing for. PC monitors, they're not real televisions. And you'll also find that different televisions behave a little differently. Some will look washed out if you don't use TV color safe. Some will bleed where the white colors will bleed into adjacent pixels because they're too white. The extra white spills out into adjacent pixels. So look for blooming like that. Look for washed out colors. And make your own judgment about this. One caveat, do make sure that you do it consistently through your app. You don't want to have color safe controls and non-color safe images, because mixing and matching is usually worse than just doing it right completely or not doing it at all. So don't mix and match, but try to do it consistently. And so just to recap here, this is our final app. We've done scaling. The system automatically scaled it for us to be an appropriate size. We have focus rectangles. It makes sound. We have the view button hooked up as our custom keyboard example. We have full tabbing functionality available. You could also plug a keyboard into your Xbox and tab around it on an Xbox if you so desire. We've handled that overscan area of the television where we've put decorative content into the part of the screen that may or may not be visible. And we've added sound.
Awesome. So yeah, just to wrap up, Nick just covered like all the stuff we sort of did in that app, and we talked about the 10-foot experience and tailoring and having one UWP. We dove into game controller and remote and talked about interaction modes and all the buttons and the inputs and tuning XY focus and focus engagement and focus visualization. We talked about presenting on the TV and UI scaling and TV safe areas and colors and sounds. And we saw this, I think, really cool app in Timely. There's a lot more that we didn't get to talk to and go into more depth on. So some more things you want to look at is the design for Xbox and TV guidance. It's very comprehensive. We're really excited. It's a great effort to put it together, and that's the link for it. We also didn't cover today the mechanics of setting up your Xbox for development and remote deploying and all that kind of stuff. It's very important, of course, to make apps for the Xbox, and all that kind of documentation is available from the second link. Of course, we'll be down at the garage over the course of the event. People have been there. You can also check out some coding challenges related to Xbox and adaptive UI and other sessions related to UWP and UI and design in Xbox. So thanks again, and we look forward to seeing your app here on the Xbox. And we'll hang out here and take some
I think they're about to kick us off the stage, but we'd love to hear your questions. We'll be around here, and if we're not right up here, we will be outside and answer as many questions as you got. Thank you very much.
Thank you.